Bryan is also from the National Weather Service in Topeka, and he will be our second speaker for the morning. So Bryan, the stage is all yours.
You have the clicker. So this. Y'all hear me? Good morning. Like she said, I'm with the National Weather Service in Topeka. I've heard there's a few storm chasers in the house. Is anyone a storm chaser out here? So a good handful of you. So was the end of May last year in Kansas not some of the best chasing conditions you could have ever? So who chased the day before out in Dodge City on the 24th? Did anyone see the tornadoes out there? A few people? How about the day after, the moderate risk day on May 26th? Anyone see any tornadoes that day? Yep. So actually today I'm going to talk about the day that was in between that could have went unknown if it were not for one storm that we had in our local CWA. So I'll just put I'll give you the answer before the question. This was the storm reports from May 25th. There was basically one storm in Kansas. It was quite significant. As many of you know, we had a tornado that started in central Kansas and pushed eastward, and it was on the ground for 92 minutes. Continuous. It never lifted. It was continuous on the ground for 92 minutes. The challenges that we had that day, so it was basically a 3-day severe weather outbreak in Kansas. The first day out in southwestern Kansas. Central Kansas was the second day, but we had limited forcing, and I'll get into that here in a little bit. And then the third day when we had the upper level support that came out, we had widespread convection. So what were we forecasting? How are we communicating this to our partners and the local public? So this was the forecast discussion that we issued the morning of the event. We knew that we had a dry line that was going to set up somewhere across our western counties. And winds were really veering behind the dry line, so we knew we could get a dry line bulge, which could favor a local area of backing winds ahead of the dry line. We also had convection from the overnight, or that started out in Dodge City's area and pushed into our area overnight, that put out an outflow boundary, and we thought maybe there could be a local environment where those dry line and outflow boundaries intersected, where there could be a potential for possibly strong tornadoes. However, we were dealing with a cap, and I'm sure a lot of you know what a cap is. We had really warm air aloft that may preclude any thunderstorm development at all. So it was a challenge to relay the message of you could either have no storms, or in this case, you could have a tornado that's on the ground for 90 minutes and was up to a half mile wide. So this was some of the social media posts that we put out that day. Obviously on the right, this was the next day. This was May 26th. We were already in an enhanced risk, so a lot of focus across the meteorology community was definitely on the next day with the enhanced risk that it became a moderate risk the next day. We had a slight risk out for central Kansas with the potential for maybe a few storms, but like I said, with the capping inversion that was there, we didn't know if we'd get storms at all. So SBC was kind of in our shoes. There was a lot of uncertainty with what was going to happen with the storms that day. So they started off with the morning day one outlook of a slight with just a broad brush of 2% tornado potential with a 15% hail and wind threat. As we go ahead, you would think that the storms would resolve themselves throughout the day, but they didn't. The short-term models actually did not provide a lot of guidance. So SBC and ourselves, we still didn't have much confidence in actual thunderstorm development, so they actually shrunk their slight risk just for portions of south central Kansas. They did include 5%, I believe. Oh, maybe that's the next one. They still just were at a 2% tornado risk, but they did shrink their hail and wind potential. As we go to the 20Z SBC outlook, they did go ahead and include a 5% tornado chance for south central Kansas, but it did not include the Chapman or north central Kansas areas. So we'll go over some of the mesoscale analysis of the day. First off, we'll start aloft with the 500 millibar chart. So as you can see, we had the large trough across the western U.S., which would come into play the next day on May 26th. But as for May 25th, we didn't have a lot of upper level support. It was all driven by mesoscale boundaries and low level features. So this is a surface map. As you can see, we had the dry line across central Kansas that had pushed eastward. across central Kansas, pushing into southeast Kansas, we had this axis of deeper moisture to the west of that red dash line that you can see. And it was causing a bit of convergence along that zone and producing some cloud cover, but that was about it. You can see the remnant outflow boundary there in the purple. It did arc up into northeast Kansas with just your broad low pressure across southeast Colorado. As we put on dew points, you can see we did have a nice stream of moisture up into central Kansas, up into the Salina area with dew points in the mid-70s, which is a very juicy environment. So we throw on mixed layer CAPE. This RAP analysis from 22Z says we did have about 4,000 joules of uncapped CAPE, which may have been a little bit overdone with the cap that was in place that day. And the box and whisker plot there on the right is Rich Thompson did some research on significant tornadoes and the parameters that were involved. So you can see we had much CAPE, a lot of CAPE in comparison to most significant tornado days. Our mixed layer LCL heights, we were well in the range of having low enough cloud bases to produce significant tornadoes with our LCL height, somewhere between 750 and 1,000 meters. As we go on to our 0 to 6 kilometer shear, it's marginal. Typically, for significant tornado days, you don't have just between 30 and 40 knots of 0 to 6 shear. So as we throw on our low-level helicities that we had, like you said, only about 150. It's sufficient for tornadoes, but typically you don't get your long-track violent tornadoes like we had this day. Do our 0 to 1. Typically, you want more than just 100 joules of helicity for significant tornadoes. So our significant tornado parameter, it was a 2, which it lies in the range of their research for significant tornadoes. But like I said, it's nothing significant yet. I want to throw on the surface vorticity because this did come into play later on. But I want you to focus. Basically, you see the yellow star. That's basically, I highlighted that over Chapman. So if you look to the east, there's not a lot of surface vorticity here at 22Z. So here we'll show a RAP sounding. It also shows that we're uncapped. This is from Salina, by the way. But I want you to notice the hodograph. The low level shear is not very impressive, but your 0 to 6 shear, it's sufficient for supercells. So this is the first storm. We did get one storm to develop across central Kansas just before 23Z or 6 o'clock. This is what it produced. This is what we were looking at. This is from Tom Doolin. A lot of the pictures and videos will be from Tom Doolin. He was on the storm as many of you were. So the first tornado then produced 16 minutes later. We had a weak tornado that lasted about a minute. That's what it looked like. The picture on the left is from Dylan Killerin, and Tom did have a video of just a brief tornado. It's really hard to see, but you can see the funnel there in the middle. Okay, so obviously, looking at that tornado, that is not a half-mile wide violent tornado. So what changed? What changed? So we'll put on our surface observations. And the one thing that we noticed, if you take a look at the winds in Abilene, they backed. We have winds almost due east to Abilene. I wish I would be able to. Is there a laser on this, Jillian? Okay. All right, so if you notice, these surface winds at this ob right here are much more easterly than they were just 2 hours previous. And during the real event, it was very difficult to notice why this happened. But after we analyzed the after fact of what happened, it was pretty noticeable why this happened. So basically, all the large-scale features did not change in that 2 hours. We still had dew points in the middle 70s. Our mixed layer CAPE, still at 4,000. It says it's uncapped CAPE. Our mixed layer LCL heights were still the same, between 750 and 1,000 meters. Our 0 to 6 shear had not changed. We were still between 30 and 40 knots. Our low-level helicity, this is what changed. So our low-level helicity is now, our 0 to 3 kilometer helicity is now between 2 and 300, which is an increase from between about 150. So it increased 100 in that 2-hour time frame. And our 0 to 1 also increased from about 100, and now it's between 150 and 200. So why did this happen? So the significant tornado parameter also increased because of our low-level helicity increasing. I want you to notice the surface vorticity. So previously, the 2 hours before, there was virtually no surface vorticity located east of Chapman. And now you'll notice, while it's subtle, there is some surface vorticity there in the blue contours east of Chapman. The reason that this happened, well, here's a wrap sound. You'll notice that the surface winds did back, like I showed in the surface obs. The wrap was also picking up on the back surface winds. And the reason that this happened, we'll take a look at visible satellite. Nothing impressive here, but as we go in time, you'll notice an anvil shadow that develops. From that supercell that developed northwest of Salina, it actually cast an anvil shadow, because this is 6, 7 o'clock in the evening, so the sun is beginning to set. I believe it sets about 8:30 or 9 this time in May. So as we go in time, you'll see this anvil shadow spreading out to the south and east. If we go to the last loop, so you can clearly see the supercell, but you'll see this boundary that is set up from this anvil shadow in this yellow contour. This is the outline of the anvil shadow. And it's basically co-located where we saw that increase in surface vorticity. The other feature that we noticed, while there's not a lot of research been done on piggyback supercells, there was actually an elevated supercell that was just in the rear flank downdraft region of the parent supercell that was producing tornadoes. Like I said, there hasn't been a lot of research done on this yet, but just in general talks at the office, we're thinking that it has something to do with the precip from the elevated supercell behind the parent supercell. All of its precip is being blown northeast, so you're not getting a lot of cool air being rushed into the inflow region of the parent supercell, but actually you're getting, as the air descends from the elevated supercell behind, it's actually warming due to adiabatic warming, and then you're actually getting buoyant air being fed right into the updraft of the supercell. So this is kind of the storm schematic that we were dealing with. Like I said, we had the parent surface-based supercell ahead of the elevated supercell behind. We had our anvil shadow that had a lot of surface vorticity just there on the gradient of the thermal gradient. The other thing to mention is the bunker's right-moving supercell motion was to the east-southeast at 12 knots, which, based on the configuration of the anvil shadow, it was almost parallel, which we think played a big role in the duration of the tornado. So this is just after 7 o'clock, 7:06 p.m. to be exact. We were sitting at the office. I actually worked that day when we were sitting at the office going, well, we had one brief tornado that was on the ground for about a minute. I'm not sure if there's a big concern for large tornadoes, and then we start receiving reports of this lowering meso, and we are beginning to become a little bit concerned. This is a video from Tom as well. You can see the whole low-level meso.
Damage to windows and vehicles will occur. Tree damage is likely.
Tunnel.
25 p.m. Knowledge around 7:30 p.m. This includes interstate 7
funnel and begin to form.
267 and 270. Take road now. Move to a basement or an interior room on the lowest floor of the sturdy building. Avoid windows. If you are outdoors.
So, just 1 minute later, we had our first tornado reported. This is also a video by Tom. It doesn't look like anything impressive on radar yet. It does have 55 knots of rotation velocity, although it is small. So, it is a significant tornado, but at this point in time, it's not large. Here's another video of it touching down. Then our next video, Dylan graciously allowed me to use his video. Tornado was becoming larger in time. Still has about the same rotational velocity, but it's beginning to increase in size. This next video kind of shows that. Doesn't look like much, and then he pans to the left, and there it is. This is the cycle where it goes from being more of a stovepipe tornado and it is starting to become the wedge as it crosses the road here. I'd also like to notice, hopefully they're not here today, there's a car that you'll see disappear and then it reappears all of a sudden. I think they're beginning to mention, where's the car at? And then here in a brief moment, you'll see the car. Here it comes. Here comes the car. You could say they got very lucky. Very lucky. So this was just 3 minutes after the initial tornado had touched down. We're talking 4 minutes later, we have a bona fide large tornado on the ground. The rotational velocity still is just about 50 knots, but this video is also from Tom. This is just 7 minutes after its initial touchdown. We're looking at a tornado. And remember, the bunker's motion on this was just at 12 knots. So it's moving east-southeast at around 15 miles an hour. So the duration it's over one spot is quite long compared to most tornadoes. So we'll skip ahead to 10 minutes later. It now has a rotational velocity of 62, which is pushing the strong to violent threshold. Basically, we look at, there's been some research done for kind of nowcasting strength of tornadoes based on their rotational velocity, which I guess I should have explained this further. Rotational velocity is basically the average values of the inbound and outbound values that we get in the storm relative motion. So at this point in time, it's increased about 10 knots. It's now up to 62 knots of rotational velocity. And this tornado, or this picture was taken from the Solomon exit. I'm not sure if a lot of you are familiar with this part of the area, or that part of the area. This is the Solomon exit on I-70. So they're looking to the north-northwest at this large tornado. You can also see the low-level meso is very pronounced as well. So we'll skip ahead about 20 minutes. The tornado did go through a bit of a cycling period, although it never did completely occlude, but it did weaken. Now the rotational velocity is back down to 46 knots, and the tornado itself is not as impressive looking at this point in time. This picture was taken just northeast of Solomon. You can see it's much smaller than it was 20 minutes earlier. So at that point in time at the office, we're thinking, well, maybe this thing is beginning to occlude. Not so fast. Just 5 minutes later, now we have another increase in strength. We're now up to 58 knots of rotational velocity, and we go to 757. It's still continuing to increase. We're up to 62 knots of rotational velocity. The correlation coefficient is now showing up as a debris ball. We once again have a bona fide tornado. We weren't receiving any pictures at this point in time, as the tornado may have become rain-wrapped during this point in time. I do want to point out from 7:51 to 7:57, it was determined at our office. We did issue our first tornado emergency for Chapman, as we thought the town was going to take a direct hit. This is the first that's ever been issued by our office for our area. I'm sure you'll remember back April 14th of 2012, we actually issued a tornado emergency for the Oaklawn area in Wichita, as their office took shelter, as they thought that tornado was going to impact their office. So as we go ahead here, I just want to show just how close this tornado did come to impacting the city of Chapman. So at just before 8 o'clock, we now have a 78 knot rotational velocity tornado, which is on the threshold of being EF4, possibly EF5. We go ahead. It's still maintaining its 70 to 80 knots of rotational velocity. We're 66, just shortly after 8 o'clock. This is 8:06. We still have our bona fide tornado on the ground. It's crossing Interstate 70. Still have a tornado emergency for Chapman. Now, this is where I want to zoom in on the city of Chapman itself. So this is 8:19. The tornado is approaching Chapman from the west. It has a rotational velocity of 64 knots with a debris signature that's very large. We know we have a large tornado. That's the reason we put out the tornado emergency. But the folks at Chapman, as you know, they got hit back in 2008. This tornado became very, very close to the city. So at this point in time, this is where the tornado is at 8:19. It's about 1.5 miles or so west of Chapman, moving east, but the tornado itself is about 1/2 mile wide at this point in time. So where I have the dot there, that is the center of the tornado. So if you can imagine, 1/4 mile or so on each side is actually the full width of the tornado. This is, I think 2 minutes later. This is at 23 after 8. Still have the large tornado. Now it's just centered about 1 mile south-southwest of Chapman. Still very, very concerned with the city taking a direct impact from this tornado. As we go ahead, now the tornado is due south of Chapman, and this is where they got very lucky. So if we throw on the point where the center of the tornado is, and we look, so it's about 1/2 to 3/4 mile south of the city. But if you can imagine this 1/2 mile wide tornado, 1/4 mile on each side, the town got missed by 1/4 to possibly 1/2 mile. That's it. And some of the damage that we saw just outside of Chapman is devastating, which I'll show here in a little bit. So by now the tornado is southeast of Chapman, and the office kind of sighs a little bit of relief, knowing that the city has just been missed. Although there was damage from the inflow winds of the tornado. And Tom kind of shows a video here of the tornado from the west side of Chapman as it just slowly skirts south and to the south of the city. So what you're seeing here, this is the tornado. And he's looking west-southwest right now. He's driving on the main drag of Chapman off of Interstate 70. The one thing I'd like to point out, you don't see anyone in the streets. All the people have taken shelter, which is great. They've all taken warning and taken shelter. Southwest of Chapman by about 3/4 of a mile, and he's continuing south out of the city. I promise the video wasn't this choppy earlier. We'll go ahead and see. All right, so this is 34 after 8 o'clock. We are now in the dissipation stage of the tornado, thankfully. It's now been on the ground for almost an hour and a half, and it's now southeast of Chapman. There's not a city in its direct path anymore, so the office is kind of sighing a relief that the city got hit, like I said. So this is at 34 after. This is the tornado. It's now more of a traditional cone-shaped tornado versus the large wedge that we had on the ground just previous. And then at 37 after, the tornado is now fully dissipated. The tornado was definitely in its weakening stage, and it may have already lifted at that point in time. So this is a full hour-and-a-half radar loop of the tornado, and I'm in awe every time I watch this. I cannot believe that it was on the ground for a full hour-and-a-half. So just narrowly missed Chapman just to the south. I'll go through that loop one more time for you. You'll notice the debris signature and the correlation coefficient there on the bottom left. As it gets just to the south and west of Chapman, it just gets very large. So this is the rotation velocity of each scan that we got in the lowest level, the half-degree slice, throughout the life cycle of the tornado. As you can see, this is obviously what we're looking at during the tornado, this chart here. So almost the entire life cycle of the tornado, it's at least a strong tornado with it had its peaks of the violent in its initial stage and then there at the end. So when it was going through Chapman, or near Chapman, it was in this stage right in here. You'll notice the dip that it had when the tornado briefly weakened and cycled. Although it never lifted off of the ground, it maintained its contact with the ground, but it did weaken slightly. So what were we saying during the tornado? The new advancements with social media. We have 800 megahertz radios that we talk with our emergency managers, Jillian, during these high impact events. So we were not sugarcoating anything. This is, I guess that slide isn't working. Okay. Anyways, so we were posting large tornado on the ground to Facebook, Twitter. We were retweeting people's pictures, just trying to make sure everyone knew of the dangers of this storm. Which, based on the videos that we saw in Chapman, it looked like everyone was taking warning and taking shelter. The good thing to note, there wasn't a single injury or death that was attributed to the tornado. So the aftermath. Although the city of Chapman did not get hit, there was at least 20 farmsteads that did take a direct hit, whether they had significant damage or total loss. And I'll go through some of the pictures here along the damage path. So it was rated an EF4. There was some speculation initially of possibly EF5, but our official rating was EF4 with winds upwards of 180 miles an hour. It was on the ground for 26 miles, and like I said, it was on the ground for 92 minutes. Its peak width was a half a mile wide, and like I said, there was no injuries or deaths attributed to the tornado. So the first damage point that we had was north of Solomon. It was rated an EF3 based on the damage there. This is some of the damage that I believe Chad actually went on this survey. This is the damage that they saw there. If we go a little bit further east, this is northwest of Abilene, about 6 miles, I believe. They found EF2 damage to this home here. Continuing to the east, this is now northwest of Abilene, about the same distance, 6 miles or so. It was rated EF3. As you can see, the exterior walls of this home are basically demolished, with the interior walls remaining. Now we're just to the north of Abilene. Initially, I guess I didn't mention this, there was some concern with the city of Abilene with its initial track a little bit more south and east that Abilene could be impacted, but then as you can see with the damage track there, the tornado did take more of a left turn and go due east there for a few miles before its southeasterly track took a hold thereafter. This is some of the damage north of Abilene. Going a little bit further east, now we're northeast of Abilene. We found EF3 damage once again. It looks like this home was completely destroyed, but I believe why it has just an EF3 rating is the structure of the home wasn't exactly sound, so they weren't able to rate it any higher than an EF3. This is where we found the strongest damage. This was 1 mile west of Chapman on, I believe it's old US 40, if anyone are familiar with that out there. This is about 3/4 of a mile or 1 mile west of Chapman. This brick home was leveled. completely leveled. You'll see the tractors. I believe there was other tractors that were flipped and thrown out into this field to the southeast as the tornado came over. This lady in this home was actually home at the time. She actually, I believe, took shelter in this back area of the home. She did, like I said, there was no injuries or fatalities from this tornado, but the walls of the home did come down on top of her, but it maybe protected her from the actual storm itself. She did note that the duration that the tornado was there was a long time. I mean, I'm sure if anyone's in a tornado, it seems like the tornado was there for a very long time, but in this case, it probably was there. The duration it was over that home was probably quite a while with its slow movement to the southeast. So this, I know there's possibly some structural engineers here. We weren't able to use this damage in our survey just because there obviously hasn't been any studies done on what kind of winds it takes to bend railroad tracks. So this is old US 40. This home is just to the left of these train tracks. And yes, the train track should be parallel to the tracks ahead. But the tornado actually picked up and shoved these tracks over. And then we're not quite sure, but it looks like possibly part of the track there on the right was actually broken, right in there. They actually may have snapped the rail. But due to uncertainty in what kind of winds that takes, we weren't able to use it in our damage assessment. But it was co-located with that brick home that I just showed previously. So this is EF2 damage. This was just southwest, probably about a half a mile southeast of where the EF4 damage was found. This home did sustain some damage, not quite like the previous home. Now we're southeast of Chapman. This home sustained probably enough damage where it's probably going to have to be bulldozed. I'm not sure if they did or not. This is actually a picture I took. I was probably a week after the tornado happened. I actually went and followed the track of the tornado myself, and some of the most significant damage I saw was this river valley. It's off the top of my head, I can't remember which river runs just south of Chapman, but this whole forest area along the river was just debarked, and the tree trunks were just snapped. So finally, it wasn't just this 90-minute duration tornado that we had, but this supercell, it actually lasted over 6 hours, starting in central Kansas, and I'll put the loop up here. It went on to produce 2 more tornadoes, southwest and southeast of Topeka in Osage County. And there were signatures on radar that suggested that these tornadoes were also strong, but being in the Flint Hills of Kansas, we weren't able to find any damage, fortunately. But just the longevity of this supercell was quite impressive. So this is about a 6-hour loop of the whole storm. And with that, I'll open it up to questions. That's what I have for the Chapman tornado of last year.